Hey guys, this is Mr. H. I am going to do question 32 from the January 2026 Algebra 1 Regents exam. Basically, they've given us a quadratic equation and they want us to use a quadratic formula and they want us to express our answer with the simplest radical form, right? All that means is they don't want decimals. They don't want irrational numbers. They want you to leave it with the square root in there, but they want the square root simplified if it's possible. All right, so now this one is pretty straightforward. So it's the A is 2, the B is a -4, the C is a -3, and then we're just going to use the formula. By the way, it's on the reference sheet. If you don't remember it, don't have to memorize it. It's going to be a -4 plus or minus the square root of a -4 squared. Always put these numbers inside parentheses. And then this is going to be 2, this is going to be a -3. Then on the bottom, it's going to be 2 times A, which is 2. All right, so now, if you do this and this is worth 2 points, I think, on the exam. I think 2 or 1, but this should be an easy 2 or 1, because all you're doing is plugging those numbers into the formula. Now, the part that we need to focus on is the b squared minus 4ac. That's always the determinant. Tell me if it's going to be rational, irrational, if it has real roots, imaginary roots. So this is what we need to focus on. So all I'm going to do from here is I'm going to let the calculator take me home. So I'm going to go, I store 2 into A, a -4 into B, a -3 into C, and then I'm just going to literally type in b squared minus 4a times c. Boom. So we got 40. Now I'm going to use menu 23, and I need to determine if that's a perfect square, if it's simplifiable, if it's not. All right, so it says 2 to the 3rd power times 5. So now I am going to go to the iPad and I'm going to finish this up. So that's it. So now I'm going to rewrite this as 40, and I can rewrite that as 2 times 2 times 2 times 5, which is what this is. I just expanded it out. Remember my rule, you're just looking for pairs. Every pair that you find, you can bring outside. So that's the only pair that I have. So this is going to be 2, and then 2 times 5 is 10. So this is the simplified form of this radical. So the square root of 40 is equal to 2 times the square root of 10. Now that I have that, I can finish this up. So a negative times a negative is going to be a +4 plus or minus, 2 times the square root of 10. I just take that and put it right over here. And then on the bottom, it's going to be 4. Now, if you get to this point, that is worth 3 points. But you should see that all of these are even numbers, so you can divide out of 2 at least from all of them. So your answer is going to be 2 plus or minus 1 square root of 10 over 2. That's it. That's your answer. Can't do anything more than that. Now, here's what I'm going to do. I'm going to show you a way to check this. Okay, make sure you're in the right ballpark, at least. All right, so all I'm going to do is I'm going to type in the quadratic formula using the letters. So there's going to be a -b plus. We don't have a plus or minus key, so we got to do them one at a time. And then I'm going to do the b squared minus 4ac. I'm actually just going to go up and copy that part. And then down here, I'm going to go 2a. Now, so that's the quadratic formula, at least for the right root or right 0. And then I do that. And of course, it's going to be a decimal because it's irrational. But now what I'm going to do is I'm going to type in my answer. And when I press enter, they should match. If they don't match, that means I've messed up someplace. So let me move this over here. And then I'm just going to type in, I'm going to do control divide for stack fraction. And then I'm going to go 2 plus, and then I'm going to do the square root of 10 because that's what we had, simplified 2. And then on the bottom, it's going to be 2 as well. And then I press enter. Now it should match, and they do. So now that means that basically this answer is equivalent. I just simplified it and kept it as a radical. All right, that's what you're doing. That's your answer. And I'm going to stop and I'm going to post this.